Well, first off, I'd like to start off and thank everyone for taking the time to attend today. I'd like to start by introducing myself. Hello, my name is Lance Zurich, and today we're going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, both of these sets are designed for conducting a project-based class where students will be required to design and build a series of original prototypes based upon their own research and activities, and each set includes standards-focused curriculum created especially for Studica by noted educator and STEM expert, Tom White. So today we're going to start off where so many technology-focused presentations for education start these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM being, of course, an acronym which stands for science, technology, engineering, and mathematics, what they are essentially talking about is the urgent need to prepare our students with the background they need to successfully compete in the job market that they're going to graduate into. Now, in the employment market that once greeted our grandparents or maybe even our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now, students must be prepared to enter a world that is increasingly focused on programming, increasingly focused on automation, IoT, and rapid advances in all aspects of technology. So in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. Now, this is of course why so much of the emphasis in education over the last decade has been on developing STEM skills. Every new advantage we enjoy, such as the tablets and smartphones that we all use daily, was created because of individuals who helped to make those advances. Countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances and preparing their own students to take their place in the future workforce. Here in the United States, we also need to prepare the next generations of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but to be part of the next wave of advancements we rely on to stay competitive on the world stage and to maintain our stature as a world power. As I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, let's now move right along to the main topic, which is of course mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. Well, just how prized? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. So while, of course, the students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they need to start developing the habits and the career focus as early on as possible, in high school, if not even in middle school. Now, the dilemma for educators, whether in the classroom or in the homeschool, is finding ways of introducing this kind of subject matter to students in a way that gets them interested and involved in the learning process, not just memorizing obscure facts or ideas only to regurgitate them for a few tests, then promptly flush them from their memory. To best help students to be successful and to really encourage them to consider pursuing further education in subject matters such as this, educators need to be able to present the material in a way that makes it relevant, which means answering the eternal student question, well, why do we need to know this? It also needs to be engaging in a way that holds students' attention better than rote textbooks and lecture presentations, something that has visible real-world applications in which the students can get involved in doing things hands-on. It is with this dilemma in mind that we created the Studica Mechatronics programs. Now, these two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject, were created to provide all of the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet current academic standards. Each of the two Studica Mechatronics program sets has its own detailed day-by-day curriculum document created especially for Studica by noted educator and STEM expert Tom White. The curriculum comes as a downloadable PDF, which is available for free with the purchase of each set. This curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program. This means that solving the problems that arise in each unit requires the students to be actively involved in the research, the design, the trial and error experimentation and activities, and the building of actual working prototypes that will provide the required answers. And students won't do this alone. They'll be asked to work in small groups or teams of 4 students each. This will help to develop the soft skills that students also need, maybe just as much as they need to develop technical skills. And by soft skills, of course, we mean things like communication skills, teamwork, adaptability, problem solving, and leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials each group will need to enable it to address all of the design projects presented throughout the course of the curriculum. The curriculum is designed to enable teachers of all backgrounds, even teachers from non-science or technology-focused disciplines, to have the information they need at hand to properly prepare them for conducting the activities and to increase their comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each unit. There are also special tutorials on familiarizing students with the building systems they will use to address the projects presented in each unit. The units in the curriculum are designed as a series of projects. Each of these projects is presented to students in the form of an engaging real-world style scenario where students must work together in small teams, again, teams of 4 students per group. And in this way, they're going to create a solution to the problem. The project units each contain embedded academics. At the end of each unit, the students will be required to make a formal presentation of the prototype they have created to address that unit's real-world scenario or problem and explain their reasoning for their solution. There is a technical literacy task driven by each of these projects. As students work to address each project, they will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Again, as required by each project, students will be asked to create original prototypes and any required programming-based solutions, and also to maintain detailed documentation during the entire process. Now, as I mentioned at the very start of the presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. Tom is a noted educator who's been involved in teaching STEM and technology since the 1970s, designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director for Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, the standards addressed in the Studica Mechatronics program are the most widely accepted standards currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. Now, as I mentioned earlier, the programs are designed to be project-based. This approach helps to answer those eternal questions: why do we need to know this, and where will we ever use this? That too often arise when students are presented with technical subjects that might seem abstract in their purpose. Here, they see firsthand why these things are necessary and why they're useful. The concept of working in the small groups to solve the project or problems helps students to develop the high demand skills that employers look for. Skills like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. In this project-based format, subjects are integrated. The math is integrated with the reading, the writing, and so on, which is ideal for STEM education. And also, because of the manner in which students must approach each project, with the research, the testing, and the group give and take to provide just a few examples, it allows for a much deeper exploration of problems than traditional teaching methods might allow. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project, you should see variations in their prototypes and their solutions. Now, this can be because of creativity, it can be because of differences in research and approaches taken by each group, or it could be for other reasons. But in any case, students can see firsthand that problems can have many different answers, and that often there is not one right answer, but many. Each project in the curriculum presents students with the opportunity to plan, organize, and conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, in the prototyping, the testing, the evaluation, and redesign phases of each solution. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for teams of 4 students. The team approach, as stated before, helps promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you're going to need to conduct the program, with the exception of the programming software, which I will address after, and that can be purchased in either single user licenses or affordable school site licenses if you need something that big, is included in each box. Everything else you need is right there. Also, access to the free curriculum download is included with the purchase of each set. Whether you buy 1 set or however many, you get access to that curriculum document. Also included are all of the building materials which students will use in the creation of each of their prototypes. These materials are from the unique Fisher-Technic building system, and among the components included in each set are also 2 robotic controllers and 2 power supplies. Now, that might beg the question, so what is Fisher-Technic? Well, to those of you who may not be familiar with Fisher-Technic, it's a flexible and innovative construction system. Now, unlike other popular construction sets designed to simply stack, Fisher-Technic was created with more of an engineering mindset. The core building block in the Fisher-Technic system is unique in that it allows attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts in the Fisher-Technic system are designed to slide together and lock in place. And because there are hundreds of different parts available, it will also help you and your students to address very specific design needs. Just to give you a little bit more background, Fisher-Technic was created back in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations used in the construction and automotive industries. Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Now, besides Fisher Technic, Mr. Fisher was the inventor of synchronized flash photography back in 1949, as well as the creator of the expanding nylon wall plug, which is often used in conjunction with a screw or a bolt to help anchor heavy objects to walls. His company, the Fisher Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, and they also produce a number of components used in automobile manufacturing, as well as providing consulting services related to automated processes. With that said, let's begin looking at each of the two individual sets. We'll start off with the Studica Introduction to Mechatronics Program set, or for those of you who like acronyms, you could refer to it as SIMP. The set is designed to help provide a well-rounded, comprehensive introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. The curriculum contains enough activity and material to fill approximately 45 academic hours. Now, as such, we recommend this program set for insertion into regular related class activities, or for use as a short class unto itself, perhaps for after-school program use, or of course for homeschool use. The curriculum created for this set is standards focused. Again, using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle schools or high schools, or again, for addressing the same grade levels in a homeschool environment. Each set contains a collection of over 700 Fisher Technic building components, and this means everything from gears, wheels, axles, blocks, sensors, and so much more, as well as the 2 robotic controllers and 2 power supplies. Again, robotic control software is required and is sold separately, and we're going to address the specifics of that in just a little bit. Now, the curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. There are also activities included to address the following areas that come up during the course of the curriculum: sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using the software and robotic controllers, working with sensors such as the digital switch and the digital photo transistor, working with open loop and closed loop programming, digital branching, analog sensors such as the photocell LDR, analog branching, more analog sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, let's first take a look at what's covered in the second set. Now, this is the Studica Teaching Applications of Mechatronics Program, and in this case, the acronym for this set is STAMP. The set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. The set includes access to the free downloadable 401-page curriculum document, in this case entitled Mechatronic Applications, also by Tom White. The activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. What this means is essentially this set can be seen as a more expansive version of the material touched on in the previous set, and is designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day, 5 days a week, or the equivalent, every week for a full academic year. Again, this set is designed for offering students a standards-focused, project-based learning experience and is designed for use in middle school, high school, or for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher-Technic building components, and once again, this means a wide array of gears, blocks, sensors, axles, and much more, as well as 2 robotic controllers and 2 power supplies. Once again, software is required for this set and is sold separately. Now, there are twice as many project units included in the Studica Teaching Applications of Mechatronics Program set as with the set we previously discussed. And they include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and that's followed by project units focusing on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeding system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided for various activity materials for students to utilize. And these include sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flowcharts, using the programming software with the robotic controllers, open loop programming, sensors such as the digital switch and the digital photo transistor, closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, analog sensors such as the photocell LDR, the NTC resistor, and the potentiometer, and a section on working with data. Now that we've had a look at how each set differs and the subject-specific material covered by each, let's instead now look at exactly how the curriculum for each of these sets is structured. Now, both versions of curriculum share the same format when it comes to the structure of each of the project units. And as already discussed, each version will include tutorial materials, activity materials, standards, and supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. Now, what we mean by that is that besides the elements I just mentioned, each unit is designed in such a way as to enable teachers from all types of backgrounds, and this includes non-science and non-technology focused backgrounds. It's designed to allow all of these teachers to quickly become comfortable with delivering the material by reviewing each section before they present it in class. Each unit includes the following: an introduction, the purpose of the project, the concepts to be addressed, an outline, all of the standards that are being met, assessment rubrics, the essential question, the student scenario, which once again is the real world problem, a daily plan, vocabulary words, and various resources. Now, in the following section, we're going to look at each of these a little bit closer. Each unit starts with an introductory section and the purpose of the project. Now, just as you would likely gather from that name, this is the section that provides a brief description of the topic that we will be exploring in the coming days and activities. This is also the section that seeks to clearly spell out to students the answer to the eternal question, why are we doing this? The next section focuses on the concepts to be addressed in this unit, and these can be thought of as the broad ideas that will be explored and the core information that students should take from this project that will be essential for them to understand and utilize not only today, but to draw upon as they move forward in STEM fields of study, and we would hope STEM-related careers. Following that, we have the outline. Now, in this section, we drill down more specifically to what will be addressed in this unit. Now, as the example shown on the screen now is taken from a unit that addresses aspects of programming, You will see that we touch upon areas such as the methods for writing programs, for example, flowcharts, word problems, and so on, various program characteristics, open or closed loop, branching, digital, analog, subprograms, and so on. The next section of each unit focuses on the specific academic standards which will be addressed in that unit. As you will see, this includes college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for grades K to 12, and the standards for technological literacy. Each project unit also contains rubrics, and this is going to include both the rubrics for the specific project being covered, as well as general rubrics for literacy tests. Next up is the essential question. Now, this can be kind of thought of as the big picture question that will be focused on in each of the smaller individual activities to be addressed in that unit, and of course, all the aspects of the larger project, which students will be asked to complete in this section. The student scenario is where the specifics of the project to be addressed are finally detailed, all of which is presented in the context of a real-world style scenario, where students are presented with a problem which they must work in groups to solve together. The problem will require students to design a unique and original answer, usually in the form of a working prototype, along with whatever programming may be required. Now, if you look closely at the student scenario shown on the screen now, you will see that the project in this unit has each group of students taking on the role of a design team employed by a firm that manufactures garage door openers. Now, in this particular case, students will have to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are spelled out, such as, again in this case, the use of limit switches, meeting certain safety codes that require a method for sensing if anything is in the way of a closing door, and the incorporation of an automatic light. Now, as discussed previously, each group of students will be tasked with creating both a unique and original prototype, and in this case, that's of course the garage door opening system, as well as any programming needed to control this prototype. Now, along the way, they will also be required to document the entire process in both a design notebook and a digital engineering journal. And in these documents, they have to note all the research, notate all the trial and error experiments, and they have to keep copies of all design sketches and revisions and anything else that they're doing as they work towards the final project. Now, at the end of each project unit, each of these groups of students will be required to make a formal presentation in front of the class, during which they demonstrate their prototype and their programming solution in action, much as they would be required to do for an actual employer or a client in the real world. Next is the daily plan. This is the section that spells out clearly, both for students and for teachers, what will be expected of students, how the teachers will conduct the day's classroom activities, and what specific subject matter will be covered. Now, some days may involve discussions, other days may require more research, or it might require building small projects that help to provide the building blocks students will draw on to complete their larger projects as described in the student scenario. Now, in short, you can think of the daily plan as kind of a roadmap. Now, you see, too, that along the way, as different aspects are addressed in each day's activities, such as, for example, what is required in a design notebook, or how to use the control software I keep mentioning, working with the controller, or working with flowcharts, or what have you. In each of these sections, or each of these instances, there are links to sections which will provide further instructions specifically on how to do that, and information, background information they may need, and what have you. So there's links throughout the document for all of that. Now, at the end of each unit, after the daily plan, is a section containing vocabulary, which is, of course, important words and terminology introduced during the project unit, as well as a selection of important resource materials. Now, these resources can contain a mix of different types of material. It can include, often it's carefully vetted websites and video links. It can also include PDF documents, PowerPoints, and other materials. Now, besides the project units, each version of the curriculum also includes a section devoted to learning how to use the Fisher Technic building system. Now, this includes information on how each of the parts fits together using the pin and groove assembly method, identifying the various types of parts, from the various types of girders and blocks included to the different types of axles, gears, rivets, and so much more. And in this section, students also get to build a basic sample model to help familiarize them with how the system works before moving on to the projects that they're going to be required to do in each unit. And as learning about and maintaining proper documentation is one of the areas stressed in the course of the curriculum, there is a section which details just what defines each type of documentation listed on the screen now and what is required for each of these. As you'll see, they're going to have to learn about design process, the engineering notebook, design documentation, problem statements, design briefs, testing protocol, project management plan, and an engineering report. And as the process of conducting project-based class activities may be unfamiliar to some teachers, there's also a section that discusses specifically conducting a project-based STEM education class and the benefits of doing so. So let's just review each set again briefly with pricing this time. Now, first we have the Studica Introduction to Mechatronics Program set, which is designed as a standards-focused project-based introduction to the core concepts of mechatronics. The program is conducted with the use of a highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with materials in each set, will provide educators with enough material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer short classes, after-school programs, or use it for homeschool use. The standards-based materials designed for use in middle schools and high schools, as well as by homeschool parents seeking to address STEM and mechatronics at those grade levels. Now, the physical materials in each set includes a selection of over 700 components from the Fisher Technic building system. And again, this includes everything from sensors, blocks, gears, and so much more, all of which will be used to construct the prototypes required in each project unit of the curriculum, as well as 2 robotic control units and 2 power supplies. Software, again, is required for using these controllers and is sold separately. Again, each set is designed for use by a group of 4 students at a time, and the pricing on the set starts at just $6.99 each for a single set, with classroom size quotes for 20 students and up available upon request. The other set again is the Studica Teaching Applications of Mechatronics Program set, or if you like for short, STAMP. This set is again designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics. The program is based around the highly detailed 401-page curriculum document entitled Mechatronic Applications, again, written by noted educator and STEM expert Tom White. This document, like the one for the previous set, is a downloadable PDF document which can be accessed with the instructions included inside each box. Now, when used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. Again, what this means is this set is designed specifically for those educators and homeschoolers who are willing and able to offer a daily dedicated class period of 50 minutes a day, 5 days a week, or the equivalent on this subject for a full academic year. Again, the standards-based materials designed for use in middle schools and high schools, as well as by homeschooling parents seeking to address STEM and mechatronics activities for these grade levels. Each box for the STAMP set contains an assortment of over 1,200 components from the Fisher Technic building system, again, including various blocks, girders, gears, sensors, axles, and so much more, as well as 2 robotic control units and 2 power supplies. Software, of course, is once again required and sold separately, and it's available in either the single user licenses or very affordable unlimited school site licenses. Now, in this case, each set is designed to provide enough materials for 4 students at a time, and the pricing for a single set starts at just $7.99 a set. And again, classroom size pricing for over 20 students is available by quote upon request. And as I mentioned that software is required, let me address that as well. The software in question is the Fisher-Technic RoboPro software, which is graphic programming software. And what this means is that it uses a flowchart style design, which utilizes various icons, which students have to arrange and link to create the programs used for each of these models. It's ideal for teaching the fundamentals of programming to users of all levels. And the pricing for it starts at a single user license is only $36 each, and the unlimited school site licenses, meaning that you can have unlimited users at a single site or building with this license, 1 computer, 100 or more if needed, and the cost for that site license is only $120 per site license. Please note that these are not subscription prices, and these are not annual licenses. These are non-expiring licenses that you can access as long as you have the software disk, which comes with each of these, and as long as you're able to install them on a compatible Windows-based desktop or laptop computer using Windows version 7, 8, or 10. And at this point, I would open it up if we have any questions. If you do have any questions, there are 2 ways that you can ask me. If you go on your Zoom toolbar, there is a question and answer pull-down menu that you can catch right in the middle of the toolbar. If you open that up, you can type questions in there, or you can use the Zoom webinar chat window. And I see that Marina has a question, so I'm going to wait for that. Okay, no worries. If anyone does have any questions, I will actually, going once, going twice. Oh yes, we will send out Joyce, we will send out a recording of this session. No worries at all. I'm just going to flip ahead to this screen. If you still have questions, you could still type them in, but if you did have questions, if you did have anything you wanted to ask that you didn't want to address right now, I wanted to bring these numbers up and the email addresses up. So how do you take the next step? Of course, you could contact us to request a quote. We can put you in touch with your dedicated educational representative from Studica. We have representatives representing different territories of the US, so we can put you in touch with them. You can call us directly at the number 888-561-7521. If your question is more generic, you can email us as well, info@studica.com. If you'd like to email me directly about any aspect of anything I've discussed today, Fisher-Technic system, what have you, my email address is up there, lance.zurek, lance.zurek @studica.com. Going back to the questions, I see Carolyn has a question, is there a Mac version? No, unfortunately for this, there is not a Mac version. It is strictly a Windows-based program. Although I would say if you got some sort of a virtual Windows type program for your Mac system, however you're doing that, you should be able to use the software on that. The only thing I would say again is the software is currently only available in disk form. So if you have something where you need to do a download on the software, we probably run into a problem. So just letting you know that up front. Anyone else? Anyone else have any questions? Okay. Well, in that case, I would like to, once again, thank you for taking the time to attend today. If you have any questions whatsoever, I will go back to that, lance.zurek@studica.com or info@studica.com. Thank you for attending, and we look forward to speaking to you very soon. Take care.